All right, wait, hold on. We are recording. Okay. All right, Nick, you want to get us going?
So this is our CS222 final project called Pantry.
My name is Connor Cunningham.
I'm Patrick Cunningham.
I'm Colin Fox.
And I'm Nick Elias.
Here we go. We'll start with a high-level overview.
Okay, so kind of like what our app does is we have our virtual pantry, which pretty much what that is supposed to do is you're supposed to be able to um input input all the ingredients, and it will list all the current ingredients you have. You can add and remove them, and you can also update it using the grocery page. We'll go into the export button a little bit more later. And with this virtual pantry, it'll actually take that information of all the ingredients you have, and it will give you a list of all the recipes you can make with those ingredients, and it will update every single time you update your ingredients list. And yeah, and then we also have the image input. That's kind of like that's kind of like the main thing we got going on here is the machine learning aspect of it. So pretty much what you can do here with the pantries, you can take a picture, you can upload it with a photo, or it access your camera itself, and it will just take a picture of all the foods you have or an individual food, and it will be able to read it and send it to your pantry so that that's just another way of inputting it. So yeah.
All right. Here is the competition or the competing products for our app.
So here are some of the competing companies or applications that we had for our app. But what these apps didn't have was our image recognition and it being able to curate recipes based on like what the user's ingredients were. And we also have our virtual pantry that uses machine learning, which was something that was very unique to our app.
For sure. Motivation.
So our motivation, little mission statement. As college students, we are always looking to maximize the quantity and quality of food that we eat on a limited budget. We were tired of opening our fridges or pantries and thinking we have nothing to eat here. We were looking for a simple way to learn what we can cook with the items that we already have in our homes.
All right, time to talk about our demo. Oops, sorry. All right, new share. All right, so here we have our video for our demo, and I will just start playing from the beginning. So the first thing that you can see here is we are in our grocery page, which is one of the features that our app has. It allows you to add ingredients to a grocery list that you can then export to your pantry list. So if you say you see a recipe that requires milk, then you can just add milk to your ingredients list. And then once you go out and buy milk, you can hit export, and then it'll move all of the ingredients in groceries into pantry. So you see, once we hit the export button, it clears out the list of grocery ingredients and transitions all of them over to the pantry ingredients. And then we see that the person then hits the delete button on eggs, and it deletes and sends a request back to the server to then update the database that holds the user's ingredients and deletes egg and updates that response. So then here we see that once we click on the actual specific users, we are able to see the different recipes that are curated based on the amount of ingredients we have. We see pancakes has 2 out of 7 ingredients, chocolate souffle is 2 out of 8, Wiener Schnitzel is 1 out of 7. The ingredients will be presented in orders of the amount of ingredients that you actually meet. So the ones that you have the most ingredients for will be at the top and the least at the bottom. And it will not display ingredient or recipes unless you own some of the ingredients. And then you see the user clicks on one of the ingredients and it outlines the name of the recipe, the prep time, the actual measurements of the ingredients, and then the steps to actually make the recipe. So this is Colin. Do you want to talk a little bit about our feature tab?
Yes. So pretty much what our feature tab was supposed to be is that if we were to release our app, it would be able to gather a bunch of information from all of our users, and it would be able to I guess what I'm trying to say is it would be able to like get the top recipes that everyone is looking into right now. But obviously we didn't have that. So we were able to choose some of the top recipes that we all liked, and we were able to display those information. I also would like to go into how we were able to like share this information between screens. Because I did work a little bit on that, at least on the front end side of when you click on it, it is able to display in order the name, prep time, ingredients, and the actual recipe itself. And it has all of it contained in a nice little orange box. So yeah, that's pretty much it for that.
All right, so now we're moving into the scan function of our app. So we are able to go just into our pantry button. And once we hit this orange scan button in the top right, it opens the user's camera. Here's me with my iPhone. You can see the user walk over to their fridge as you would on a Friday night. Take out some of the ingredients that you have, this being an egg. I take a photo of the egg. And now, this photo is then encoded in a base64 encoding, sent to our Google Vertex AI endpoint. And then that's where it starts to like kind of process it. And then if we give it a few moments, we can see that an egg appears. So from the photo that we took, from the photo that we took, we were able to get an egg displayed. And we also have a settings page. Do you guys have anything to say about the settings page?
No, but why doesn't Nick go into some of the things he also worked on too?
Yeah, so one of the things is on the bottom of the screen, you can see the menu bar. So basically this just uses React.js's default navigation options, and basically it gets sent to the page to whichever one you click on as a parameter, or the parameter is the page, and then they're just little pressable buttons. You click them, it sends you to the page. And then there's also some different animation options added that are different from the default ones, as well as like a custom header. There is no, I took away the header and just made the footer with the bottom.
Okay, so that is it for our demo. We can move on to the rest of our presentation. Can you guys still see the presentation, or do you need to reshare? You need to reshare. Got it.
Reshare, yeah.
Okay. Is that good? Okay. Yep. So the next thing we'll be talking about is basically just the breakdown of the technical architecture of our project. Basically, our project is split into three main components. The front end, which is obviously what the demo showed, the actual app interface and the thing that the user interacts with. Then the front end communicates with the back end, which is made with Node.js. And then obviously the scanning machine learning aspect was its own separate component that we made with Tensorflow to do image processing.
Okay, so again, to kind of reiterate, like what the front end does, it displays the ingredient information in pantry and in grocery. We also didn't really get a chance to showcase this, but Nick also worked on a scroll view. So if you were to input 15 different ingredients for your in the grocery or ingredients page, or even and have more than three recipes show up in your in the recipe section, it would you would be able to scroll through it. It displays recipe information in the recipe section, and it exhibits a usable interface and that is intuitive to navigate through. And also, as Patrick just said, it is able to we're able to access the camera through the front end. Yeah.
So the front end just sends post requests and get requests, with the body of the post request just being whatever information we either want to input or delete, or same post request will be used to talk to the server and send information, bring it back. And then all of that is connected in React with the state functionality of React, which will automatically update it in the app.
All right. Anything else you guys want to say about the front end?
No, but I mean, the language we used was just JavaScript, and then the subsets of those of React and React Native and those libraries. But yeah.
Okay. So then to go into a little more detail about the backend functionality, some of the main roles that the backend does, you saw it in the demo, but it has to keep a database of a user's ingredients. That is both grocery ingredients, which we saw in the grocery list, and then also the user's pantry ingredients, which those ingredients are then used to search through our database of recipes. And then based on the matching ingredients that we find in recipes and our pantry ingredients, the backend server filters those recipes and uploads those to the user's active recipes, which are then displayed in the front end. Additional roles that the backend plays, as you see in the interactions, that it also it takes the photo that is sent to us from the front end. It then saves that photo to our computer, and then activates the Python machine learning files that is contained in the ML component, and then handles that data, takes that post request, updates the server updates the user's ingredients based on whatever the image classification came back is, and then sends that data back to the front end. So how this was made was mainly with Node.js. This is JavaScript, helps with JavaScript backends, making servers, and then Express was very helpful for the route handling, sending to different pages, different get and fetch requests. And then MongoDB was how we used what we use for a database to actually store all of this information. All right. And now to talk about the machine learning part. So the machine learning part is used to scan users' ingredients to be able to take photos of like their pantry or their refrigerator, and then it'll be able to like input that automatically into your groceries page or your pantry page. This interacts with the front end by receiving the photos that it takes, and then the back end is able to connect this photo to the endpoint that's housed on Google Cloud, where it's able to access the TensorFlow model to actually process and make this prediction. The languages and libraries that we used for this, we trained our own model, our own image classification model for this. There's a lot of available TensorFlow models that were available to us. It was hard for us to find one that was really fine-tuned to food. A lot of them are more specified for just everyday objects such as phones or erasers or pencils, but it was nice to be able to, we trained our own model. We started doing this by using a library called Darknet, which is just a simple library that you can use for training a model. We were able to do this on Google Colab to be able to use the GPUs that they provide, because my MacBook Air does not have great access to the type of GPU that's required to train a machine learning model. After we trained this Google Colab on Google Colab, we used a Python function to convert the weights file that we created from training into a TensorFlow weights file. because there's slight differences in the labels for the weights files between a TensorFlow and what we originally trained, which was a YOLO v4 model. So there's a difference there that isn't supported by Vertex AI on Google Cloud. So the whole TensorFlow model runs on a Google Cloud service called Vertex AI, which basically grants you access to a GPU of your choice from a server location in the United States. So this one's currently running in Iowa, I believe. But once we were able to convert to a TensorFlow model, we were able to put this onto Vertex AI and create an endpoint that we could pass JSON requests to, which was the images. And after that, we could just push back the responses that we get from our TensorFlow endpoint through a Google Cloud Python function, which ended up giving our app the output that it had. And for a demonstration or a diagram of how the machine learning starts. So as you said, the front end will take an input image, which is then handled by the back end. And in the back end, we must first encode this image because we can't just pass a PNG to an endpoint because we need to have a JSON request to be able to pass to the endpoint. So we encode the image in a base64 URL encoding, and then it's formatted in a JSON request. This JSON request is passed to the endpoint through a Python function, which is then fed to the TensorFlow model. And through that TensorFlow model, it's able to print out both the confidence score for the image, the class that you've given it, as well as, if we wanted to, it gives display boxes for the labels that it found. But you're able to process this to determine the classes that it noticed, which is the output, and we can add this output to the app at the end of the cycle. Now to talk about some problems that we ran into.
So for the first problem that we encountered, it had this occurred when we first tried to access the camera of the user and take a photo. With our test models for the Python file, we were able to just test off of images we took from Google, which are typically around 80,000 bytes of storage. But when we took a image off of the camera from our iPhones, it was about 6 million bytes. So it's a huge difference in size. And that resulted in the Python file, not being able to process the image because the base64 encoding was incredibly long. So this was a big problem that we, for a long time, had a problem overcoming. But for the solutions for how we figured it out, the image picker launch camera async, basically how the front end takes the photo, accessing the user's iPhone. When you actually take the photo, you have different specifications like the size and width and aspect ratio. And one of the things that we found was the quality setting, which we found that we were able to reduce. It's kind of a percentage, like 1 would be max quality, 0 be, least amount of quality. We found the sweet spot about, I think, 0.1, I think, gave us the best, best size. Obviously reduced it from 6 million bytes all the way down to half a million bytes. It was a huge difference, but it still preserved the quality of the image and was still able to be recognized by the ML model. The second thing we used to reduce the sizing further was Python image library, or also Pillow. This allowed us to take the photo from the computer, from the file. I was then able to resave the image to the computer in a smaller format, and this again reduced the image size from about 500,000 bytes to 400,000 bytes. So overall, we went from 6 million byte image all the way down to a 400,000 byte image. And the reasoning for why we decided to do this was these were very straightforward and simple solutions. The quality setting was 1 line of code, and then the Python image library set or functions were only 3 or 4 lines. They're very straightforward. And again, as we said, it preserved the image quality well enough to still be able to be used by the machine learning component. It was still able to recognize apples and eggs, even when the quality was drastically reduced.
And the second problem that we ran into, I touched on it for a second, but from the start of creating this model, the model was originally trained on Google Colab, and a very accessible and user-friendly way to train a model is to use a weights format called YOLO v4, which is very easily accessible to like a Google Colab user. TensorFlow is kind of not intuitive to be able to download onto a Mac, especially. There's constantly new implementations of TensorFlow coming out. So it ended up just being easier to try to train a YOLO v4 model on Google Colab. But the issue that we quickly ran into was actually trying to move this image recognition software off of Google Colab and into something that we could actually use, like something in VS Code or something eventually to lead to our app. And the root of this problem was the weights file that we had. AWS and Google Cloud, neither of those really support a lot of YOLO v4 access or YOLO v4 weights files. What they end up supporting is mostly is TensorFlow, because that's the most common form of image recognition that most people use. So we ended up having to do was convert the weights files that we had created from our Google Colab training into a TensorFlow model. Once we had done this, we were able to host through Google Cloud. We were able to access a GPU for just a small, low cost. And we were able to access a GPU whenever we need to. So whenever we make these requests, we're easily able to access a GPU to be able to handle and process these requests. Again, the reason for this was the YOLO v4, while it did work well for training the model and giving basic demonstrations of how well it works, Vertex AI, which is the service that Google Cloud uses, doesn't actually support YOLO v4. So unless we had converted to TensorFlow, we wouldn't have actually been able to implement this into our app. So the result of this, we were allowed to run our machine learning model on our app. And I believe that is all that we have prepared for our presentation. Do you guys have anything else that you would like to add? If not, thank you very much for sitting for our presentation. We had a lot of fun creating this project, and we think that we really made something that we're all very proud of. So thank you very much. Share.